NASA's space probe has sent a shocking warning to Earth. Voyager 1 has earned the trust of science enthusiasts across the world for its unprecedented journey through the depths of space. Originally designed for a 5-year lifespan, this resilient spacecraft has defied all expectations, enduring for nearly 5 decades. Now, we are on the verge of a groundbreaking discovery as Voyager 1 just detected unknown objects passing by in space. What are these unidentified flying objects? Join us as we uncover how Voyager 1 detected 300 unknown objects passing by in space. As we marvel at the breathtaking splendor of Earth's natural wonders, the cascading waterfalls, towering mountains, and vibrant ecosystems, it is difficult to realize that our planet is only a glimpse of the grandeur that awaits us in the vastness of space. For centuries, scientists have pondered the mysteries that lie beyond our solar system and the watchful gaze of the sun. Fortunately, Voyager 1 emerged as man's most ambitious attempt to seek answers to the timeless question. This remarkable spacecraft has ventured beyond the limits of our most powerful telescopes, collecting first-hand data about the vast expanse of interstellar space and relaying it back to Earth. After decades of an extraordinarily successful voyage, Voyager 1 has delivered a startling message that has left scientists astounded. Voyager 1, NASA's most trusted interstellar spacecraft, just announced that it has detected 300 unknown objects passing by in space. But before we find out the mystery behind these unidentified objects, let's first explore one of the most remarkable stories of man's exploration of space. In August 2012, an extraordinary milestone was achieved by the Voyager spacecraft. After a remarkable journey, Voyager 1 officially reached the outermost boundary of our solar system, crossing what is known as the heliopause. However, this feat was by no means an easy task. As Voyager 1 ventured farther away from the Sun, the availability of sunlight to power its instruments and systems diminished significantly. The primary source of power for the spacecraft comes from 3 radioisotope thermoelectric generators, RTGs. These ingenious devices convert the heat generated by the natural decay of plutonium-238 into electricity. Over time, the declining heat output of the RTGs has resulted in a reduction in available power. This decrease in power has a direct impact on the operation of various systems on board, including scientific instruments, data transmission, and communication capabilities. To conserve energy, certain non-essential systems and instruments have been deactivated or placed in a dormant state. However, as the power continues to decline, critical systems may require further optimization or even shutdown to prolong Voyager 1's operational lifespan. The stark reality is that if no action is taken, Voyager 1's ability to function will be severely limited, and even if it manages to continue operating, its usefulness to us may be greatly diminished. Adding to the challenges is the vast distance between Voyager 1 and Earth. As the spacecraft ventured into interstellar space, the strength of the signal transmitted from Voyager 1 weakened considerably. Currently, it takes over 21 hours for signals to travel from Voyager 1 to Earth. The weak signal, combined with interference from background noise, presents a significant obstacle to successful data transmission and reception. Moreover, the transition from the heliosphere to interstellar space exposes Voyager 1 to vastly different temperature conditions. Within the heliosphere, the spacecraft was closer to the Sun and experienced higher temperatures. However, as it delved into interstellar space, it encountered extremely low temperatures. These temperature extremes can impact the spacecraft's materials, electronic components, and systems. Thermal stress and the expansion and contraction cycles resulting from these temperature variations could potentially affect the structural integrity of certain parts. Extreme cold can cause materials to become brittle, leading to possible fractures or degradation of seals and connectors. Furthermore, the temperature variations also influence the performance of the RTGs, which are designed to operate within specific thermal ranges. The cooling of the RTGs further exacerbates the power challenges previously mentioned. Compounding these issues is the presence of a sparse distribution of dust particles within interstellar space. Although these particles are minuscule in size, they pose a risk to the Voyager 1 spacecraft. When the spacecraft encounters interstellar dust, these particles can collide with its exterior surfaces, causing wear and tear on protective coatings, antenna surfaces, or other sensitive areas. The accumulation of dust on the instrument's optics or sensors can interfere with their functionality, degrading the quality of the data collected. Additionally, the Deep Space Network, NASA's global system of antennas for communicating with deep space missions, has to allocate limited resources to receive Voyager 1 signals. This allocation of resources makes communication opportunities with Voyager 1 much more infrequent than ever before. The continuous decrease in signal strength further complicates the retrieval of data and the transmission of reliable commands. What are the achievements of Voyager probes? The achievements of the Voyager twin probes stand as a testament to human ingenuity and the boundless spirit of exploration. These remarkable spacecraft, more than 4 decades ago, embarked on a journey that forever changed our understanding of the distant worlds in our solar system. Their early observations of Jupiter and Saturn's moons shattered preconceived notions and left researchers in awe. These moons, once thought to be inactive and scarred like our own moon, proved to be vibrant and dynamic, teeming with geological activity. Among the Voyager probes, Voyager 2 stands out for its extraordinary milestones. In 1986, it made history by becoming the first spacecraft to venture close to Uranus, providing humanity with the first up-close look at this enigmatic planet and its moons. Just 3 years later, Voyager 2 accomplished yet another groundbreaking feat with a flyby of Neptune, revealing the wonders of this icy giant. To this day, Voyager 2 remains the sole spacecraft to have ventured into the realms of Uranus and Neptune, a testament to its pioneering spirit. As the Voyager spacecraft continued its epic odyssey, NASA implemented various measures to prolong its operational lifespan. Over the past 3 years, non-essential components and heaters have been deactivated, conserving energy and ensuring that these intrepid explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030, a testament to the resilience and durability of the Voyager probes. For the dedicated scientists and engineers who have been involved in this extraordinary endeavor from the very beginning, the culmination of the Voyager missions is both a moment of pride and a touch of melancholy. Their unwavering dedication and tireless efforts have far exceeded their initial expectations. The wealth of data returned by the Voyagers has provided invaluable insights, fueled numerous scientific discoveries, and sparked the imagination of countless researchers and space enthusiasts. What truly sets the Voyager probes apart is their meticulous design as stable platforms. With a rotation rate over 15 times slower than the hour hand of a clock, these spacecraft were engineered to minimize visual blurring as they captured images and data while hurtling through the vastness of space. Even before their encounters with the outer planets, their impressive imaging capabilities began to amaze scientists and the public alike. Months before reaching Jupiter, the Voyager spacecraft began transmitting images of this gas giant, captivating audiences at NASA's Jet Propulsion Laboratory. These early images showcased the mesmerizing swirling clouds and the iconic Great Red Spot, leaving observers in awe. However, it was the discovery of active volcanoes on Jupiter's moon, Io, that truly stole the spotlight. This moon, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected peculiar signals from Io, which were confirmed by the vivid images they captured. Towering volcanic plumes and a surface scarred by volcanic material ejections were unveiled. Pele, one of Io's most prominent volcanoes, has erupted with a force 30 times greater than the height of Mount Everest, covering an area nearly the size of France. While the cameras of the Voyager spacecraft were eventually powered down to conserve power and memory before their journey into interstellar space, it is worth noting that the photos they captured did not include Mercury and Mars for various reasons. In addition to the Voyager 1 and Voyager 2 interstellar probes, NASA has also operated other notable spacecraft, such as Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed by Pioneer 10 on February 17, 1998.